Was carried out to Question 10. An investigation was carried out to compare the rate of metabolism in a species of cricket, which also has a complicated name, which we'll just call species of cricket, at different temperatures. 5 crickets were placed in a sealed flask which was fitted with a carbon dioxide CO2 sensor as shown in the diagram below. And then we've got the flask which has been immersed in a water bath, and in this case at 5 degrees C. Flask was put in at 5 degrees C, left for 10 minutes. And the CO2 produced per minute was then measured. This procedure was repeated at 10, 15, 20 and 30 degrees C. Results are shown in the table below, and by that they mean here. So 5, 10, 15 and 30, you have got an increasing rate of CO2 production. Give a reason why the flask was left for 10 minutes at each temperature before each reading was taken. Now there are several ways you can put this. I think the one that I tend to go with all the time, because it's always the same one if you've got living things, is to allow the living things, so the crickets, to acclimatise. So that means that they are now acting in the way you would expect them to, sorry I can't spell, acclimatise, to that condition. So you could also go to allow the condition to be stable, so actually get to the right temperature. If you just dunk them straight into a 5 degree water bath, if they've come from 20 degrees, they're still sitting at the 20 degrees. So you need time for that to stabilise. So either for the conditions to stabilise or allow the living things that are in there, i.e. in this case the crickets, to acclimatise. A control flask should be included. Describe the control and explain its purpose. So what we're looking at here is, I'm laughing slightly because you get some very strange answers for this. The control should be showing that the CO2 sensor basically doesn't change if you don't have crickets, because the crickets are the things we're looking at. So what we're looking for is the same setup without crickets. But how you do the without crickets is the bit you get some very odd answers. So you could go with dead crickets. You could go with no crickets at all. You could go with something which is the same mass as the crickets, so taking up the same space in the flask, which it should be doing, and generally you go with glass beads. But I have seen people saying things like plastic crickets of the same size, without crickets, and however you do that. The explanation with that one is the same one that's come up several times in the data handling, and you've got to be very careful because it's about this investigation. So this is a control, so you can't just say though it's to give you a comparison, which is what a control does, but it's about this investigation. So what we want is it's to show that it is the crickets, that is the cricket's metabolism. That creates the results. So you need to link it specifically to this experiment. Right, now if I go down to the next question, you're asked to plot a line graph to show the results. So I've recopied the results here. I can maybe make that a little bit bigger actually. There we go. So first off, nappy rule, what you changed goes across the bottom. So we've got 0, 5, 10, 15, 20, 25 and 30. Every check mark with a point. We put temperature, degrees C. Now up the side, I know this is a long title, but I don't care, you lift it in its entirety from the table. So you're going to write rate of CO2 production units per minute. And we're going up to 1600, and I think we're still going to start as 0, but let's just check. 2, 4, 6, 8, 10, 12, 14, 16. Yeah, start at 0 and go up in 200s. So 2, 4, 6, 8, 1000. I'm sorry about how scribbly this is, but hopefully you can still get the usefulness out of it. Right, so that gets you 1 mark. The second mark is for you plotting the points correctly and joining with a ruler. This means when you go into the exam, take a ruler. Don't expect that someone's going to wander around and say, oh, do you need a ruler? Get yourself organised before you go into the exam, okay? You need a straight edge. So 5 to, we're going to 300, so half box, so you need to be on the half box for that one for 300. 500 at 10, same deal. It's slightly annoying, I suppose, with the scale, but you are bang on for the 500. For the 800, you need to be, that's okay. It's going to, oh, unless I draw it like that. And 20 is going to be 1200. There we go. And 30 is okay at the 16. And then you neatly join these points, okay? You do not join to 0. Don't go here, because you don't know what the respiration is at 0. You don't know if it's going to be nothing. It probably will. It'll probably kill them. But if it doesn't, you know, there might be a tiny bit of respiration going on. So don't join to 0 because you have no data point there. Okay. Draw a conclusion from these results. Well, I think it's pretty clear. Okay. As you increase temperature, we are increasing, now being very careful, okay, what was the thing we were actually investigating? Going up the top, the rate of metabolism. So metabolism is obviously linked. We're just looking at respiration. So what we have here is as we increase temperature, we are increasing the metabolism. That's it. Okay? Don't say increasing CO2, because that's not the question. Conclusion must answer the aim of the experiment. Always go up and check, because quite often that's the sneaky bit to the question. And we're done.